All right. Hello, everybody. Welcome back to Comp 2450, Software Development 1. I hope that you have all had an excellent weekend. I've been having like the tiniest bit of technical difficulty up here, which is just like the tiniest bit of the ridiculous state of there are two different HDMI cables up on the front of this table, and I don't know which one is supposed to be for what. So here we are. Today, what we're going to be focusing on is some stuff that is course material. So like last week, we were focusing on this idea of let's get a sense of what the course is about, and let's try to do a little bit of introductory review. I posted up working versions or compilable versions of the code that I wrote in class on Friday up to the GitLab link that's in the lecture section for Friday's class. So you can find that stuff there. But this week, we're actually not going to touch Java at all. We're not going to be doing anything with our IDEs. We're not going to be writing any code. Instead, what we're going to be focusing on this week is we're going to start. So we're going to be beginning to be able to do this. We're not going to be able to accomplish this entire learning outcome this week. We're just going to start with this stuff. The first part of this is going to be that I want you to be able to design and then diagram a domain model using appropriate modeling techniques. So the focus today is going to be on design. And what I want you to be able to do in terms of designing a domain model is I want you to be able to make decisions about the depth of a domain model using software design principles. So I'm going to introduce some principles to you. These are principles. They are not rules. They are not rigid. They're there to help guide us make decisions about something. And the other thing that I want you to be able to do by the end of today's class is classify and describe the relationships between domain model objects. So we're going to be coming up ultimately with a set of things that represent the idea that we're trying to build something of. We're going to have some goal of I want to build some kind of software. So what are the major concepts that I have to have in the software that I'm building? And then ultimately, what are the kinds of relationships that these different things are going to have when I actually get to the point of writing code? So let's start. Let's start talking about domain modeling. Ryan Reynolds, this like piques my memory of something from when I was a kid last week. This is Ryan Reynolds. This is Ryan Reynolds when he was probably like 12 years old. This is from a TV show that was called The Odyssey. It was on CBC when I was a kid, and this was like something that I would be coming home in middle school, like hopeful that I would get to catch one. This is a different era. Like you have to hope that you're going to be able to see the show and hope that it's on and hope it's not the last one you missed. And he played this character. I believe this character's name was Finger. I don't know, but it was like a modern variation of the Odyssey, the Greek epic, the Odyssey, where it was a kid that was in a coma and he was kind of like his friends were in this world with him and he was. I've digressed already and we haven't even started class. What even is domain modeling? So what is domain modeling? What is this idea? I've used these words a few times, but this is kind of something that you probably haven't thought too much about. You've heard the word domain, I'm sure. You've heard the word modeling, I'm sure. You might have heard those things put together, but they don't necessarily reflect something that you've done in computer science. So domain modeling here, the idea is that in 1010, we had some basic tools to represent abstract ideas. The basic tools that we had when we started in Comp 1010 were primitive types. Primitive types in Java are things like int, double char, and a string with an asterisk. You know now that string is not a primitive type, or it kind of is. It's this weird sort of primitive type in Java. But you have these basic types that you can use to represent abstract ideas. Temperature in Fahrenheit is a double. Temperature in Celsius is a double. These are abstract ideas that we're representing with these primitive types. In 1010 in Java, you also learned about arrays, where you're able to have things like sequences of these primitive types. And you began to do representation of more complex ideas using these things called parallel and then partially filled arrays. Just a quick thumbs up. Do you remember writing parallel arrays in Java in 10.10? Okay. Parallel arrays in Java in 10.10 was very much just like, we're going to get to objects eventually, but this is okay for now. We're just going to tie these different arrays together, and the index at this thing says, this is the one thing, and these are all of its properties. But we don't want to talk about classes yet. So in 10.10, we had primitive types that we could represent abstract ideas with, and then we had parallel arrays and partially filled arrays where we could represent more complex ideas. And then we had static methods for behavior. In 10.20, we introduced classes. Parallel arrays are fine. They accomplish the goal that we wanted to accomplish, but the reality in Java and in OO languages, object-oriented languages, is that we're actually going to use classes to do this. And classes are named collections of properties and operations with encapsulations. So we have things like information hiding. We have that public and private keyword for modifying whether or not someone outside of that class can access it. We had collections, so we introduced things like array list. We did array list in 10.20, yes, 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 awesome. Okay, yeah, so we did collections. Arrays in Java are fine. We will continue to use arrays all the time, but we moved on to this more complex data type that was a collection. And we were using these things to represent abstract ideas that we're going to be implementing in the code that we're writing. But when we're writing those abstract ideas out, we're kind of given pretty clear instructions about what it is that we're going to be building. So like your assignments would often have, these are the classes you should build, and these are the methods that you should put into those classes. They might not have said you should put these properties in the class, but they were kind of pretty prescriptive about the way that we were going to accomplish that thing. So domain modeling for us in this course now is, I'm no longer going to be super prescriptive about what classes you should have in your projects or in your assignments or in the tasks that you're going to be working with. And so domain modeling here is effectively us taking the time to do planning before coding. We're not opening our editors this week, or we will open our editor, but for a different purpose. We're not writing Java code this week. We're going to be focusing on planning out what it is that we want to accomplish before we get to the point of actually writing any code. So the main idea with domain modeling is that I'm trying to represent high-level concepts and abstract ideas and their relationships without thinking about implementation details. So I'm explicitly not going to be talking about scanner. I'm explicitly not going to be talking about text UI versus graphical UI. I'm explicitly not going to be talking about web servers. I'm explicitly not going to be talking about how someone is going to interact with this application yet. I'm just looking to represent high-level concepts and abstract ideas that are in the domain. The domain here is going to be, this is the application I'm building, the area of the application I'm building, the topic of the application I'm building. So representation is what we're looking for, and just high-level concepts and abstract ideas. We're not going to be talking about implementation details when we're doing any of this. The goals with this exercise are twofold. First, I want to be able to communicate with my peers. So this is me being able to communicate with you, and this is you being able to communicate with the people around you, and this is you being able to communicate with the team of people that you're working with when you get to that point. This is also the people using the application that you're putting together, and you want to be able to communicate ideas about what it is that you're going to be building with those regular humans using the same kind of terminology that they are using. So I want to be able to talk to my mom and dad about what this application is going to represent, what it's going to do, and I don't want to have to talk to them about using scanner and exceptions and that sort of thing. The other thing that we're going to accomplish with this is that as taking the time to think about what it is that's going to go into this application, we're going to be getting a clearer idea of what it is that we're going to build. So I know, because I did this in Comp 1010 and Comp 1020. You get your assignment and you just start coding. Just like fingers to the keyboard. I got to start writing my main method and I've got to read this file and I've got to do stuff with this thing. I just start coding and my application kind of grows as I'm working through the implementation of this thing. The exercise here is I want to spend some time thinking about it. I want to spend some time thinking about what this thing is before I actually start writing any of this code. I'm working on a bigger project. I'm working with more people. I'm working with people who are real humans that I need to be able to talk to about this. And so I want to get a better sense of what I'm going to be building, and I want to be able to talk to those people. Domain modeling as an exercise starts from two different places, or can start from two different places. First place that we can start domain modeling from is de novo. And de novo is Latin. This means from nothing. This means I'm going to be starting to build an application that nobody's ever built before, ever. Nobody has ever built anything like this before. And so I have to start everything from scratch. This might even mean I got to make up some new words to represent ideas because these ideas don't actually fit into the real world right now in any kind of a way. The other way that we can start doing domain modeling, and this is the one that's going to be more often the case, is from an existing system. So something that is already there. We have an idea of what this domain is. We have some ideas about what we're going to start with. There is terminology that's already established within this domain to describe these high-level ideas, an existing system that we can start with, and this is what we're going to be doing in this course. Starting de novo is unusual. It's pretty unusual, and it's kind of in the realm of like academics, and it's in the realm of like you're really pushing the edge of what you're going to be doing with the software that you're building. Typically, it's going to be there's some idea of an existing system that you can start with. Some idea of an existing system, meaning there just already are other applications that do this. There's already a process that's in a business that has these abstract ideas. They're just doing it in a different way, and they're maybe not using software to represent that. In this course, the way that I want to drive a lot of the stuff that I'm doing, I'm going to be using a couple of different examples. I'm not necessarily going to use them all the time. I'm not necessarily going to be using them to actually accomplish building some bigger thing. Typically in classes, I'm going to be showing you examples of like in micro how to do this tiny thing in isolation so that you can put it towards your project and build that bigger thing. But I'm going to be using two different examples, and I'm going to try to stick to these two different examples throughout the course as we're building stuff up. The first thing that I want to use as an example is Pokemon as a game. I know that not everybody knows Pokemon, and I'm going to gatekeep Pokemon here just a little bit because there are and only ever will be 151 Pokemon. That's where it stops for me. When I need to talk about Pokemon, I will explain to you what Pokemon is as a concept so you have a sense of what it is. And this is ridiculous. Your university instructor is going to be telling you about this stupid video game that I played when I was a middle school student. Pokemon Red and Blue, that's it for me. Pokemon Yellow is pushing it because I don't want Pikachu walking around behind me. I'm not going to talk about Pokemon any more than that today. But I will describe the idea of the game, the premise of the game, the kinds of how things are going, and I will often try to bring something that I can show you what the game actually looks like in terms of gameplay to drive the ideas that I'm trying to get to. The other one that I want to use is a music management system or a music player. This, I believe, is well known enough that almost everybody is familiar with the idea of playing music. How many of you, and this is just idle curiosity on my part, how many of you have Spotify accounts? Okay. How many of you don't have a Spotify account? Okay, all right, many fewer. I'm the kind of person that does not have a Spotify account. I'm kind of intentionally leaving this too small for you to see, but you might be able to see it. This is my music collection, and I currently have about 600 albums on my phone, 660 albums on my phone. Philosophically, I just want to make sure that I own the stuff that I play. So I spend a lot of money on Bandcamp. Bandcamp is one of my favorite websites for getting music. And philosophically, I want artists to get, I want them to get the money that they deserve. That's where I'm at. But everybody here seems to have Spotify account, yes. So they have a broad understanding of music management as an idea. Or if you don't have a Spotify account, I'm sure you have music management as an idea somewhere in your head. So I want to use these two different examples throughout the course, and I'm going to be coming back to each of these throughout the class. But today we're going to be taking a look at this music management system or player. Both of these I consider to be well known, but like I said, with Pokemon, I don't consider it to be as well known as music management. It's not as universally applicable, but it is in our culture, at least in Western culture, it's in our culture. And so I want to explain that when necessary. Okay, so with our music management system and player, what I want to do is begin the exercise of modeling our domain. I want to show you two pictures here. This is an MP3 player. This is an example of the first kind of MP3 player that I personally ever owned. This is an MP3 player. At least when I had it, had 30 gigabytes of storage and not 60. But this is an LCD display here. And it can display things like the list of albums that you have. It can display things like individual songs. It can do things like basic playlist management. However, playlist management was generally done on your computer in advance as opposed to being done on the device itself. This is the second MP3 player that I owned. This is a Microsoft Zune. It was a lot more. It was a lot more. There was a lot more in this than there was in the first MP3 player that I had. This one could do things like manage pictures and videos. Zune, if you are not aware of what Zune is as a concept, it was meant to be like you could go around and share music with people. There was Wi-Fi built into it, and you could on the streets share it with people. Yeah. Why did I choose a Zune over an iPod? That's a great question. Part of it was at the time I worked at Staples, and I got a better discount on that than I did Apple products. But there was also just a tiny bit of, I don't want to have the same thing everybody else does. I wanted to do something just a little bit different, yeah. In grand sum, though, both of these accomplish the same task. Both of these are MP3 players. Both of them have some basic music management. They have the ability to work with music and albums and playlists. Here is the domain that I want us to work on today. The domain, and this is a statement that I'm going to come back to. Let's build software that will let me manage playlists for my music. I want to build software that's going to manage playlists for my music and emphasis on the idea of albums. I want to have albums in this thing. So we're going to do that by drawing our domain model. And we're going to be drawing our domain model with our hands. I've got this nice tablet that I will be using to draw our domain model out. You are welcome to use pencil and paper or pen and paper if you are very confident. I will share this with you on the course webpage. So like I said, I'm always going to share stuff that I do in class on the course webpage. So you don't have to draw things along if you don't want to. But I'm going to draw this domain model out with our hands. And what I'm going to ask you for, you can draw this out as well if you want, but what I'm looking for here is get your phone out, get your Spotify out, get something out that is a well-known system for a music player that has music management. And I want you to share with me high-level concepts. And the high-level concepts that I'm thinking about here are single words, typically, not always, but typically single words, and they are typically nouns. These are the things that I'm looking for right now. So I'm going to pop over here to my Mentimeter, and I'm going to bring this up to the side. And I'm going to start taking the ideas that you are sharing with me and drawing them out on my screen. And the way that I'm going to do that is with some circles with those words in them. Who let the dogs out? Okay. So I'm seeing right away that the word album is showing up here quite large. So album is definitely going to be part of the domain model that I want to represent in this application. The word playlist shows up a lot. This is something that I want to represent in my domain model. Favorites is really big here, and I like that. Genre, shuffle. I'm going to pick on favorites. That's one. Genre is another one that I see that's showing up here. Shuffle is a good idea, but I'm going to say that shuffle is a verb. So this isn't necessarily something that fits into our domain model as a high-level concept right now. It's something that will be part of what we do with this system, potentially, but it's a verb. So this is going to be encoded eventually as a method. I don't want to talk too much about high-level, about implementation details here, but shuffle being a verb is something that's going to show up there. Likewise, search is something that is going to be a verb. Queue, the word queue can be used as a verb or a noun, but I'm going to leave the word queue to be the same thing as playlist here. So playlist or queue are the same things to me. The word queue is very difficult to spell. You got to have just the right number of U's and just the right number of E's in there. So what else have we got here? Song, download, okay. Compilations shows up. Lyrics. A song database. I've got the word song here. And I'm going to say that a song database is a good idea, but it's 2 words. For now, we're just focusing on individual high-level concepts that we're working on. Repeat that, please. Database. Database is something that's an implementation detail that we will eventually use. Yeah. Artist. Yeah. Okay. I like that one too. Like volume or equalizer, stuff like that. Sound output, I think, is going to be an implementation detail. Yeah. I'm going to pick a couple more things from here. Play counter, I'm going to leave this one as an aside. That's something that I think is a good idea, but we're not going to have that as a high-level concept right now. Music videos? Videos, okay, yeah, I like that. That fits in with the whole Zune idea here. We're super brainstorming here. I don't really have a rule that says we should come up with 15 classes and 15 different ideas to represent this thing. Thank you for sharing all these ideas. I'm going to come back to this diagram in just a moment. I'm going to let you keep adding stuff if you want, but I'm going to pop back over here. Oh gosh, this is what our domain model is starting to look like now. I do think that these are all solidly good ideas, yes. So I'm going to scratch the word maybe from here. I think that everything that we've come up with so far is solidly a good idea. But there are too many ideas. This is an overwhelming number of things to get started with. Our goal here, remember, is I want to be able, one, to communicate ideas about the software I'm building with the people who are going to use it and the people who are around me, who are helping me work on this application. The other thing that I want to accomplish by doing this is I want to have a clearer idea of what it is that I'm going to be building. Having all of these abstract ideas here do give me a reasonable, clear idea of like where eventually I'm going to go with this, but it doesn't really give me a great place to start. It doesn't give me a great place to start working on this application. And so what I want to do here is start to think about a couple of new design principles. These are principles in the purest sense. These are guidelines. These are not rules that say you should cut this many classes from your domain modeling idea. These are philosophies, effectively. These are philosophies that are going to help us make some decisions about this stuff. So these are two design principles that are emphasizing minimalism. KISS is keep it super simple. It's among other like backronyms. You know, there are reasons that people say that these are the letters of KISS. But I'm going to say keep it super simple. I like that one a lot better. It's not demeaning to anybody. So let's keep it super simple. And Yagni is you ain't gonna need it. These two design principles, again, these are principles. They are not rule sets. They don't say delete 10 classes from your domain model. They are guiding us towards minimalism. Try to keep in our domain model effectively only what we actually need to accomplish the task that we started out with in the first place. So the focus here that I want to have in terms of minimizing the data that we're going to be thinking about in our domain model is I want to refocus back on the original idea. I'm going to give a word to this. I'm going to give a name to this idea here. Not this idea itself, but the idea that I have an idea here. I'm going to call this thing my vision statement. This is a word that you will see again when you get to Comp 3350. But for now, this is like my target. This is my idea that I want to build for the application that I'm working on. The focus of my application is I want to build software that will let me manage playlists for my music. I have three minimal sets of concepts, high-level concepts or ideas that represent this statement. A song. I want to be able to see a song. That's an important part of adding something to a playlist to me. I want to be able to have albums. I want to be able to represent a collection of music as it was intended by the artist. And I want to be able to represent a playlist. Those are the three things that I really, really think is the minimal set of domain model objects that I would have for this idea. So I'm going to pop back to my diagram here. I'm going to add a new page, and I'm going to have album. I'm going to have song. And I'm going to have playlist. Those are the three key things. This is my minimal domain model. When I asked you to open up your phone and get Spotify or whatever out, what I'm partly trying to do is maybe there's something I haven't thought about in terms of what this minimal thing is supposed to be. Part of the exercise is brainstorming. I want to get a good sense of what all these things are, but in terms of refocusing back on the core of what the idea is, to me, Franklin, these three ideas are the main three ideas in the minimal set of domain model objects that I want to have in this system. It's okay with everybody so far? Yeah.
Minimal domain model. Would it be worth it to generalize this example of, say, album and playlist together as one, make it more minimal?
That's a great question. And that's a great suggestion. The suggestion here for the recording is, could we possibly minimize this further? Take this idea of a playlist and an album and just merge them together. They are effectively the same overall big idea, some collection of music in some way, shape, or form. And I think that's an okay idea, but I think it might be pushing too far toward minimalism here. So I don't want to necessarily minimize my implementation of this yet. I think, please correct me if I'm wrong, but I think what you're starting to think about is I could make this a list in both cases. And I think you're right, you could make this a list in both cases, but now you're starting to think about implementation details of these classes. Yeah.
What's the best way to know what you don't need? What's the best way to be on this?
My advice to you on this, so trying to make decisions about what is the best thing to have for what you do and don't need, is that you're often going to have a statement like this. As part of your software project, you're going to have some guiding vision or some guiding principle that says this is the core idea of this application. And so again, for me, these three ideas kind of stick directly into this. If I go back to the other ideas that we had, so I'll pop back to this page here. Genre, I think, is an important part of a music management app, but it's not the core idea of what I have. Downloads is an important part of music management, but it's not an important part of making playlists out of the albums that I already have. Videos, I think that's an important part of music and like music culture, but it's not really an important part of making playlists out of the music that I have. So my emphasis here is very much on taking that statement that describes the thing that we're trying to accomplish and then trying to prune it down to just those things. Without going too far and without trying to think too much about how these things are going to be implemented, these are just high-level ideas that we're thinking about right now. Yeah.
Like we were trying to say, it's all we have to just begin with like baby steps, like learning alphabets before making sentences.
To some extent, yes. So like starting with learning how to do your ABCs, and this is a very North American thing, but do your ABCs before you can start to read or write. Yeah, do your ABCs before you can start to read or write. To some extent, yes. The idea here is we're trying to think about the small, I guess, atomic, maybe that's the right word here, the atomic ideas in this system. Yeah. All right. So we've got this minimal set of concepts. Now what I want to do is I want to start to model the relationships between these ideas, these high-level concepts. Relationships between classes or between these concepts are going to be fitting into two categories for us in this course. There are other kinds of relationships that classes can have, but it's out of scope for us. The first type, and this is the one that's out of scope for this course, is the is-a type of relationship. Have you seen these words before in the context of making classes? So in 1020, you talked a little bit about this. Okay, 2 people are giving me big thumbs up, and I'm grateful for that. Thank you. Is-a relationships are inheritance, but this kind of a relationship is out of scope for Comp 2450. We're going to be eventually, again, I don't want to talk too much about implementation details here. We will eventually be using the idea of interfaces and then an implementation of that interface, just like you did with stack. I actually don't know what data structure you would have done in 1020. Stacks and queues. Okay, so stacks and queues, but you implement it as a linked list or something like that. So we'll do this a tiny little bit, but inheritance fits squarely in Comp 2400. So if you're taking programming paradigms right now, this is the course where in C++ you're going to be doing lots of like hierarchies of classes that represents this is a type of relationship. In our course, we're going to be focusing on the has-a type of relationship. Has-a here is more formally described as composition. We're going to be thinking about composition of classes as a way to make relationships between them. Composition is a way to represent this, and in Java and in other common programming languages, this typically looks like it's a containment within another class. So there are two different kinds of composition, and we're going to formally distinguish these two different types. The first type is composition. So this is a bit of a recursive statement, but the first kind of composition that I want to talk about is composition. The other type of composition that I want to talk about is called aggregation. These two ideas are modeling ownership and then lifetimes of the relationship, or the lifetimes of the objects between the two relationships that are, between the two classes that are within this relationship. Ownership here means that we're going to have an idea that owns another idea. And ownership here kind of when I destroy an instance or may not destroy the related class because it's contained within or it's owned by that other thing. So composition is if I have a composition relationship between two classes, A and B, composition between A and B implies that A owns B. That means that if I delete an instance of A, I should also delete the instances of B that are attached to that. If I delete an instance of B, it doesn't mean I should delete A as well. This is a one-way relationship that we have between these things. Another way of saying this is that instances of B cannot exist independently of A. So that there has to be an A for this B to exist. I'm going to stop using A and B here in a moment when we actually annotate our own domain model diagram here, but B can't exist. This instance of this class cannot exist independently of A. There must be an attached instance of A for this thing to exist in the first place. So this is composition. Aggregation is a relationship between two classes that does not imply ownership. So if I have an aggregation between A and B, that effectively means that if I delete A, nothing happens to B. If I delete B, nothing happens to A. These two classes can exist independently of each other. So I can have an instance of this and an instance of this, and they don't have to have any effect on each other when they're removed from this system. So composition, ownership, deleting one implies deleting the other, but not vice versa. Aggregation is they can both exist independently, and I don't have to worry about deleting the other side of this relationship when I've got this. Now is I want to stop talking about A and B because that's crazy abstract, and what I want to start talking about is the relationship between the different classes that we have in this system. And I want to annotate these relationships. I'm just right now. Next class, we're going to think about how to do this a little more formally using an actual domain modeling technique called UML lines. I just want to draw lines. I don't want to obscure the idea that we're trying to get across to do with these lines. So I'm going to pop back to my diagram that to do with these lines. So I'm going to pop back to my diagram that I've got here, my minimal domain model. Start drawing some lines between these. I want a very quick thumbs up, thumbs down. And for the question that I'm asking, these are yes, no questions. Thumbs up, thumbs down. Does album have a relationship with song? Yes, no. Okay, lots of yeses. So album and song very clearly have a relationship between each other. In the minimal system that I'm trying to implement, quick thumbs up, thumbs down. Does a song and a playlist have some kind of relationship to each other? Seeing two big thumbs up from some people. Yeah, absolutely. These things have some kind of a relationship between each other. We've got one last thing that we could possibly ask this about. In the system that we've got here, should albums and playlists have a connection to each other? Big thumbs up or big thumbs down that says no, they don't need to have. Yes, they do need to have. Many, many fewer thumbs down, lots of confused faces and uncertainty. I don't think that they should have a relationship between each other. Yes.
A lot of music apps that I use, this treat albums as glorified playlists by an artist himself instead of treating them like their own separate entity.
Yeah.
So I feel like they should be linked together because album is just a pre-made playlist per se by another artist.
That's fair. So just repeating, there are some music apps that effectively make album and playlist the same concept. And this actually comes back to what you were thinking about here. In the system that I'm describing, I think that that's a good idea, but the relationship that I want to have between album and playlist is that and now I'm thinking about implementation details, but if I add an album to my playlist, I'm just adding all the songs that happen to be in that album to a playlist as opposed to adding the whole album itself. So then there's no relationship between album and playlist in the system that I have in my head here. So in your system, yes, they might be the same idea, but in my system, in my head, we're just going to keep these two things separate from each other. Is that okay?
So like an array and an array list, for example, that's two different kind of data.
Between album and song is that albums are composed of songs. And I'm going to draw an arrow that's going this way. If I delete a song, I probably don't want to delete the whole album. We can make philosophical arguments that if I deleted a song, it's no longer the album that it was, but that's a philosophical argument. If I delete a song, I probably don't want to recursively go back and delete everything else that was on that album. If I delete an album, I probably want to delete all the songs that are on that album. I want to delete that whole set of things. So the relationship that we have between album and song here is that an album is the other relationship that we have is between song and playlist. I'm going to draw the arrow. I believe that this relationship goes this way. And I'm going to label this an aggregation. A playlist is aggregated of songs. A playlist is aggregated of songs. If I delete a playlist, I probably do not want to delete all the songs on that playlist. This is us maybe knowing a little bit about what playlists are, but I believe this to be a well-known enough domain that we all have a sense that a playlist is not like the thing that you're using to delete music in your system. It's a view of the music that you have in your system. Similarly, a song, if I delete a song, I don't want to go and delete all the playlists that it has. I might have the relationship itself modeled between these two things in the classes that I actually implement. I might have some relationship because I want to know, for example, how many times this song has been played. And that was one of the options that came up in our first set is play count. The relationship between song and playlist or song and album might be that it has additional information, and I might just delete that object. But for now in this minimal system, I just have this relationship between song and playlist, and it is an aggregated relationship. The playlist is aggregated of songs. They can exist independently of each other. A playlist can have no songs in it. A song can be on no playlists. We can't have a song that doesn't have an album. It must have an album. And if we delete that album, we should delete all the songs that are attached to it. It's okay for everybody? Okay, yeah.
So speaking more abstractly here, we try to avoid a full cycle of relationships. That's why we didn't want album playlist of relationships.
So the question is asking about having a cycle of relationships. This is a contrived example, and the purpose of not adding this was not about a cyclical relationship, like a graph type relationship. It was more that I just personally don't believe that there should be a relationship between those things. So I guess to clarify why I am drawing something that looks like a graph, this is definitively not a graph, and we're not thinking about graph theory here. Yeah. But that's a fair question. Thank you for asking that. All right, I'm going to pop back to my slides. I've described here what we've described in text. Yeah.
I just got a quick question.
Yep.
So the album and song classes, I guess. Does that mean that the album class owns the song file composed, or is it the other way around?
The album class will own the songs class.
Okay.
So instances of album will be attached to instances of song when we get to it.
I see. So if the instance of the album were to be deleted, then therefore the song would also be deleted?
In a recursive sort of way.
Right.
Yeah.
Thank you.
Yeah. Okay, so at this point, you should be able to begin to design a domain model diagram. You should be able to make some decisions about the depth of a domain model using software design principles. So again, emphasis on minimalism. Given a statement, I want to take this domain model set of concepts that I've got and go back toward that small thing. You should also be able to describe and classify the relationships between domain model objects using the words composition and aggregation. So I'd expect you to be able to identify it and then use those words to actually mark up something that has relationships between it. That's it for today. I will see you all on Wednesday. Bye, everyone.